We come to a new session of financial mathematics. This is part 2, nominal and effective interest rates. Let us try to understand how to calculate the effective interest rate and the nominal interest rate. A nominal interest rate is the quoted interest rate. So when you look at a question, you will find interest rate compounded monthly, compounded half yearly, compounded quarterly. That is a nominal interest rate. And effective interest rate is the actual interest rate received in effect. So we can convert nominal interest rate into effective interest rate and vice versa. For this we have a beautiful formula. 1 plus I effective equal to 1 plus I nominal over n to the power n. What is this n? N is the number of times per year. If you see compounded quarterly, then n is 4. If compounded monthly, then n is equal to 12. Compounded half yearly or semi-annually, then n is equal to 2. So that is the main point we have to notice, and we use those values for n. And when we calculate effective interest rate or nominal interest, we consider only 1 year. Only 1 year. We don't consider 6 year or 10 year or 15 years. Okay? So we continue. Let us look at few examples. Convert a nominal rate of 18% per annum compounded monthly. Look at that. To an effective rate. So once we see 18% per annum compounded, let us look at the actual effective rate. So we use the formula. We know the rate is 18%, that is 0.18 over n. N is 12, compounded monthly. The whole power n again, that is also 12. Use your calculator very carefully. Double check your answer. Now we get 0.195618171. Therefore, the real effective rate, you multiply that decimal value by 100, we get annual effective rate is 19.6%. So although the quoted percentage was 18%, now look at the real effective rate is actually more than that, 19.6%. So ultimately the accumulated investment will yield more money when we use the nominal interest. Convert an annual effective rate of 13.5% per annum to a nominal rate per annum compounded semi-annually. So n is 2. We substitute the numbers into the formula. We have 1 plus I nominal over 2. Okay, it's going to be 1.0653 as the square root. Then we have I nominal over 2 is subtract 1. We get 0.06536388. Then we multiply both sides by 2. We get 0.1307275,753. Now, what is the rate now per annum? That is multiplied by 100, 13, 1% per annum compounded semi-annually. Look at that. 13,1%. We find it a lower percentage, but in effect it was 13,5%. So that is the difference between the effective rate and the nominal rate. The nominal rate will always lower rate, but in effect it is more than that in a year. Robin invests 30,000 at 16% per annum compounded quarterly. Convert the nominal rate to the effective rate. Use the formula, substitute the numbers quarterly. N is 4. So we get 0,169. We multiply by 100 and we get 17% approximately. So 16% quarterly nominal, actual effective rate is now 17%. Same question number B. Use the annual effective rate. Annual effective rate we got in question number A. Calculate the future value after 15 years. So we use the formula for compound interest. A equal to P times 1 plus I to the power N. Here we have 15 years. The number of years is 50. So we calculate on the calculator, we get 315,588,82 is the accumulated or the future value of the investment after 15 years. Changing interest rates. Now, we have a question, but during the period, the interest changes. The interest rate for the first 3 years is 12% per annum compounded half yearly. Thereafter, 18% compounded monthly. The money is left to grow for further 4 years. So in timeline will explain very clearly the idea behind this question. For the first 3 years, the interest rate is 12%, but it is compounded half yearly. So 0,12 over 2, 3 years, making 6 half years, 3 times 2. After 3 years, the rate is changing, 18% monthly. So it is 0,18 over 12. And how many months in 4 years? 12 times for 48. So we use a very beautiful timeline there to explain. Now we are going to calculate the future value. We use the formula for compound interest. We substitute the numbers. In one step, we can get the final amount. Rand 144,935,65. Okay, that is a question for changing interest. Another question, again, change of interest rate, 16% compounded quarterly. You underline all those. 15% compounded monthly for the remaining term, the future value. Okay, so we substitute into the formula. You can also do it in 2 steps, or we can use a shortcut in 1 step. It is recommended. The shortcut is recommended to save time. We are calculating the original amount that is invested in the beginning. That is P, calculating P. We have done it to the power minus N formula. So we can use that one here. Use your calculator. Now we have 3 questions. Just 3 questions. You can also get a lot of questions from our Metric question papers, practice all of them, try to understand the method and practice. Here we have 3 questions. The answer is also available there. After working out, after doing the question yourself, you check the answer. Additional payments and withdrawals. Look at the timeline. 5,500 deposited. Then 5 years later, 5 years, another 4,000. But the interest rate for the first 3 years, it is 14%, compounded semi-annually. And then thereafter, it is 12% monthly. So this number line will help you to understand. So we substitute the numbers very carefully. First amount is 5,500 up to 7 years. Use the calculator. Different interest rates. You have different interest rate for that money. Also for 4,000, the same interest rate, 12% monthly. Use that one for 2 years. So we get the answer on the calculator. Double check your answer. Leslie deposits a birthday gift. We have the number line. The first deposit is 14,000. And then it continues, but a 2,000 rand was withdrawn. So we minus it. Here it is not adding, it is subtraction. Craig deposits 65,000. Then a further deposit of 10,000 after 1 year. So 65,000 goes, and then another 10,000 you calculate for that. Calculating the time period, depositing 4,000, 10% compounded annually. How long? So we are going to solve for the time. Okay, value of n. You simplify the equation. You need a little bit of application of log here. N is equal to log 2 base 1,10, or you can do logarithm of 2 divided by logarithm of 1,10. We get 7,272540897. But we have to write in years and months. So what we do, we multiply the decimal value by 12 and change it into 3 months. So we get 7 years and 3 months. That is the end of part 2. We discussed effective interest rate, nominal interest rate, then change of interest rates according to the period. We have seen beautiful timeline. We practice, we get more and more questions. And keep watching the videos, all videos. Subscribe my channel and watch all the videos. Thank you. Share it. Share it to your friends. Thank you.